We are currently living the second quantum revolution, but what does it mean and why it is happening now, since quantum physics unveiled a new state of the world in the early decades of last century? The motivation can possibly be found in the Nobel Prize assignment sentence back to 2022. The Nobel Prize in Physics was assigned to John Closet, Alain Aspect, and Anton Zeilinger with the following motivation that I'm going to read. For experiments with entangled photons, establishing the violation of Bell inequalities and pioneering quantum information science. It's not exactly clear to anybody but the experimental physicists involved in the process, and it's maybe worth trying to tell what it is meant by this sentence. Photons are the basic elements of light. Light, which is striking our own eyes, can be described macroscopically as a wave. Think about the waves in a lake. But then, when you go down to analyzing what is making the thunderstorm that is coming to our own eyes in a sunny day, you can really think of it as a swarm of honeybees. The single elements that are building up what we call the wave are actually the basic essential elements that we call photons. Let me now turn to entanglement. This is something very weird. Think about twins. Twins that were born identical at birth. So what does it mean? It means that once you know the color of the eyes of one of them, you automatically and irreducibly know the color of the eyes of the second one. These are classical correlation. This is not entanglement. Entanglement is when you have quantum twins. What does it mean? It means that essentially at birth, you just know that what you know about one of them is automatically determining what you know about the other one. That is to say, until when you don't look at the eyes of one of them, you don't know which colors they do have. But once you do, then you automatically identify the colors of the other one, which is something that is not possible in a classical twin. This is something which is specific of quantum twins. And who was Mr. Bell, which is quoted by the Nobel Prize Committee? He was a theoretical physicist working at CERN, the house of the largest accelerator ever built by mankind in Geneva. He took a sabbatical leave back in 1964 and he flew to the US. There he shifted his investigation to the essence of quantum mechanics. And in particular, he focused on entanglement. And he drew on a piece of paper a series of mathematical inequalities that were driving the researchers into the interpretation of the essence of entanglement. So proving the inequalities hold was proving that entanglement was real in the quantum world. So he's one of the pivotal people in the development of the second quantum revolution. Entanglement can be considered the quantum effect. And producing entangled photons like, say, quantum twins was in the early days something essentially impossible. And so experiments and explanations related to that were only in the researcher's mind. Today, generating entangled photons is very well possible thanks to the enormous progress that we had in the technology. And it can be done essentially in every lab, which is very well equipped, by what is called the parametric down convention. It consists essentially in having a laser beam which is interacted in vacuum with a special material, a non-linear material, technically speaking. And as a result of this interaction between the incoming light, we have pairs of entangled photons that are produced. This is something that today you can see with your own eyes happening. Light comes in colors, we all know. And the colors are also the instrument that is allowing us to see whether the photons that we produce are correlated and are entangled. Imagine that the laser beam comes to me, it's interacting. As a result of the interaction, it generates a first rainbow of colors that go from blue to maybe near infrared. Each of these is actually paired with a second rainbow of colors that goes from the mid to the far infrared. Now, colors have a specific location in space, and the sections are somehow correlated. But if they were simply correlated by classical mechanics, we would not have what we do have. That is to say, when you look at the properties for each section, for instance, the number of photons, namely the intensity, this will be different depending on the fact that the two rainbows have a classical or a quantum correlation. So, to be able to assess the quantum properties of the rings, you need the Lord of the Rings, and you need to have instruments that are capable of counting single photons, like silicon photomultipliers. Silicon photomultipliers are, in the silicon age, eyes. The mosquito eyes are able to blink their eyelet whenever they are covered by a flash of photons. And you count the number of eyelets that are struck, and you get an indication about the number of incoming photons. So silicon photomultipliers are a technology that comes by research, and they are a technology which has been brought to the highest commercial level by Hamamatsu. So far, so good. So these eyes are disclosing the possibility to have the investigation of the very essence of nature to researchers. But what's next? Actually, the properties of the entangled beam of photons are essential in what is called quantum communication. That is to say, we know the security of our digital life now proceeds through keys that are used to lock and unlock the doors, that are making it impossible for an eavesdropper to get, to sneak and to sniff our own data. The doors can be opened or closed by keys. And keys can be generated and distributed thanks to the quantum properties of beam and light. This is the highest level of security. This is where the future will be in order to protect our digital life. All this comes by research, comes by the investigation of properties at the deepest level of nature, comes by technology, like the one developed by Hamamatsu.